All right, so our objective today is to understand the properties of parallelograms. Oops. So don't forget tomorrow your theorem and property cards, theorem, postulate, property cards are all due, and you're going to turn in at the beginning of the test your vocab cards, okay? So we're into chapter 5, and because we're just beginning, that means we must be on lesson 1. So make sure that you read in the lesson. So we're going to do a definition and a 3 theorems, and we're going to do a couple proofs to go with those theorems, okay? Now, here's the funny thing. Yes, we're moving on to four-sided figures, but in order to deal with these four-sided figures, we're going to still talk about congruent triangles to help us out. So that notion of CP/CTC is still going to be there, okay? All right, so let's talk about the definition of what is a parallelogram. And Kai said it. Now I'm going to add a word that he didn't use. A generic name for a four-sided figure is a what? Quadrilateral. So we're going to always use that term. So it's a quadrilateral, which means we know it has 4 sides. Quad is 4, lateral is sides. Ooh. Quadrilateral with both pairs of opposite sides parallel. Oh, that's a lousy looking opposite. That's why it's a parallelogram. Okay. So we're going to be using the notions from chapter 3 with parallel lines. We're going to be using the notions of chapter 4 with congruent triangles to help us with our proofs. Now, the symbol, shockingly, is of a little parallelogram. And most people make it in this orientation, where it's kind of slanting towards the right, but you can make it slanted towards the left. But we do want it to be slanted because we want to distinguish it from using a rectangle or square or something like that. So, first theorem is 5-1, so unfortunately no names. But here's the nice thing is the theorems in the beginning of this chapter, even though they don't have names, are short, very short. Kind of like vertical angles are congruent, they're about similar length, okay? So this one deals with something that we can prove about parallelograms. If we know that their opposite sides are parallel, then we can eventually get to that the opposite sides are also congruent. So that's what theorem 5-1 states, that opposite sides of a parallelogram are congruent. So if we have a parallelogram, A, B, C, D, and that means that segment AB and segment DC are parallel, and segment AD and segment BC are parallel. Notice that I use a different number of arrow caps so that we can tell that while I have 2 sets, those 4 together are not all parallel. That would not make sense. What this theorem says is that if that's true, then I also know that segment AB is congruent to segment DC, and I also know that segment AD is congruent to segment BC. So that's what I get to conclude. So our given would be that we have a parallelogram A, B, C, D, and what we're able to conclude or prove is that the opposite sides, segment AB and segment DC, are going to be congruent to each other, as well as segment AD and segment BC. And you might see it written as segment AD and segment CB orientation, but that's fine. Okay, so we'd be able to conclude. So if you have a parallelogram, then the opposite sides are congruent. So we could write it as a conditional statement if we wanted to. So we're going to go ahead and do a proof of this one. And again, because we've just come off of a chapter on triangles and their congruence and taken stuff from them, we're going to use that in our proof. Everybody good to go? Oh my gosh, life with a 6.5-year-old. All right, so next, let's do a proof. And we're going to prove Theorem 5.1. So our given is that we have a parallelogram, EFGH, and we want to prove that segment EF is congruent to segment HJ, and segment FG is congruent to segment EH. So just to show that I can actually go the other orientation, and we'll call this EFGH, and notice that the letters have to be in either clockwise or counterclockwise order, otherwise it won't work. Now the problem is if that's all I have, I can't do anything because all I know is that it's a parallelogram that opposite sides are parallel, but that's not going to get me to them being congruent. So what I'm going to have to do is add an auxiliary line. So whenever, I see an auxiliary line added, I'm going to have to give a reason for it in my proof. But as I add that auxiliary line, now I have created 4 angles. And we're going to label it exactly the way I have it. I don't know why they had to do funky, but they did. I think they just wanted 1 and 2 to pair up and 3 and 4 to pair up. Okay. So before I can use angles 1, 2, 3, 4, I have to give mention to where the EG came from. So I'm going to go ahead and start with the given because that's a very good place to start. Yep, let's Sound of Music going on right now, I know. So that's your given. And then we're going to draw a segment EG. Now notice that we've not drawn it so we have congruent angles, we haven't drawn it so it's perpendicular, we haven't drawn it so it's parallel to anything. So this is when we get to use the postulate 6. Through any 2 points, there is exactly 1 line. Okay. So now the only thing that I can come from the given is that I have both sets of opposite sides are parallel. So I need to bring that in. So I'm going to say that segment HG is parallel to segment EF, and segment HE is parallel to segment GF. So I'm going to go add a little bit to my diagram. Okay, so let's focus in on the HG and the EF. So I'm going to temporarily highlight them and then I'll erase it off. Let's go to here. Okay, so if I've got HG and EF are parallel and I've created this transversal, what angles have I just formed by those 3 segments? Isabel? Angle 3 and angle 4. So what I want to go directly under this first statement is the matching angles that I get from that. Okay, what kind of angles are those? Alternate interior, right. So I'm going to get angle 3 is congruent to angle 4. Okay, and the reason, sorry, I forgot to do 3, definition of parallelogram. And you can use the symbol. If 2 parallel lines cut by transversal, then alternate interior angles are congruent. Okay. Now, let's go with another. Okay. So now we've got the HE being parallel to the GF, and we've got a transversal. And so looking there, what 2 angles are formed by those 3 lines? angle 1 and angle 2, right? So that information's going to go directly underneath and I did a mess up over here, and whether you saw it or not, didn't say anything. I didn't mean to say that. I meant to say that they're parallel. I get so used to having congruent. We've been doing congruent. I haven't done parallel for a whole chapter. So what goes with segment HE and segment GF being parallel is that angle 1 is congruent to angle 2. So this is what we're talking about with orientation, that there is a direct relationship from this set of parallel lines to the angles it forms, and from this set of parallel lines to the angles that it forms. Okay, so now I'm going to go back to my diagram, and I'm going to color in some stuff. So I got angle 1 congruent to angle 2. I've got angle 3 congruent to angle 4. And I need one more piece of information to prove that these triangles that I've created are congruent to each other. So what do I need? Yeah. So even though in one triangle it's EG and the other triangle it'll be GE, we can just write it in the same orientation. And that's the reflex property of congruence. That allows me, so on the left, let's see, we've got 2 and 4 HG, so that doesn't really matter so much. So at this point, it doesn't matter what triangle I label. There's no right or wrong orientation of what goes on the left. So I can get triangle, let's go HEG is congruent to F. Now E went with angle 2, and what matches angle 2 is angle 1, so that's at G. And what matched angle 4 was angle 3, and that's at E. And what's the reason those two triangles are congruent? Angle, side, angle postulate. So let's see. Oh gosh, guess what? I didn't do that right. Why am I saying that? Look at what our concluding statement is. It wants EF and FG to be on the left. So guess how I could handle that real fast?
Symmetry.
No. Erase.
But you could do symmetric.
You could do symmetric, but it's smarter just to do this. That's why we use pencil in math. No, it's called SMART. That's what that is. So segment EF is congruent to segment HG. Oh, wait a second. We've got EF and I've got HG, but my letters say GH. So guess what? So F and G go together, and E and H go together. Okay, now I got it. Well, hopefully y'all had more sleep than I did. And then FG. Okay, now I'm totally messed up. You know what? I don't think it really matters. It really should matter, but now, for some reason, this isn't going to work out. But this is what they told me to do, so I'm done fiddling. I'm done fiddling. CPCTC, which is corresponding parts of congruent triangles are congruent, not congruent parts of congruent triangles are congruent. That would be redundant. All right. Not pointing any fingers, but there were a lot of people who did that. Not only can we prove that opposite sides of parallelograms are congruent, but we can also prove that opposite angles of a parallelogram are congruent. Now, in order to do this, it would not take one auxiliary line. Because if we look back at the last one, we could got an angle F and angle H congruent to each other real simply, right? So, but I couldn't get angle E and angle G, so what I do would draw a different auxiliary line and prove, so I go this way, and prove this triangle congruent to this triangle, and then I would get angle E and angle G congruent to each other. So that's the difference on the next one. So it would not be one auxiliary line, it would be two. But I'm going to skip that for right now and then add the last of the theorems. Oops, sorry. And theorem 5.3 would be, and here comes one more thing we could prove, which we could do, oh, well, we could prove this. Diagonals of a parallelogram bisect each other. Now that one's a more interesting one. Okay? So here's what my recommendation is. You're not going to worry about this homework tonight. Though doing a lot of it takes you back into the chapter 4 triangles needing to be congruent, which is helpful. However, I would just focus on reviewing and studying, okay? And wait till tomorrow to do this homework. All right? That's it.